All right, so for problem 53, we are trying to express this number here as a ratio of integers. So we have 2.516, which repeats indefinitely. And what we're going to do here is we're going to break it down into two parts. So we're going to break this down into the number 2 plus the decimal part, so 516, 516, 516, and so on and so forth. And the reason that we broke this down is because we actually want to look at this infinite decimal expansion as an infinite sum. So we're going to say, okay, this is the same thing as 0.516 plus 0.000516 plus 0 point, and now everything else gets covered with zeros, and then we add another 516, and then plus, let's do one more, everything else, so 3, 6, 9 zeros, and then we add a 516. And if we do the sum here, if we line everything up, we can see that the total sum is going to be in the first column, that's 5, in the second one, that's 1, 6, and then the total sum in the fourth column is 5, 1, 6, and then the sum would be 5, 1, 6, 5, 1, 6, and then and so on and so forth, right? So the important thing here is to notice that this first part here, it's just 516, and then times 10 to the minus, so let's see, there are 3 decimal points, right? So 10 to the minus 3. The second one is going to be 516, but now we have 6 decimal points. So that's going to be times 10 to the minus 6. The third one, we're going to have 9 decimal points. So 516 times 10 to the minus 9. The next one, we're going to have 516, and since we have 12 decimal points, it's going to be times 10 to the minus 12, and so on and so forth. So what we can actually say is that this expansion is going to be the same thing as summing up 516 times 10 to the minus 3 to the power of n from 1 to infinity. Because let's think about this. Let me just fix this up. If n is equal to 1, then the first term is going to be 516 times 10 to the minus 3 times 1, which is 10 to the minus 3, which is the same thing as this guy here, right? If n is equal to 2, the next term, we're going to have 516 times 10 to the minus 3 times 2, which is 10 to the minus 6, so this guy. If n is equal to 3, we're going to have 516 times 10 to the minus 3 to the power of 3, so 10 to the minus 9, and so on and so forth. So this is really, really neat, because now we can see that all we're doing here is we're taking the number 516, and then we're multiplying that by sums of decimal powers that go to the power of 3. So once we're here, we just have to arrange this a little bit to get it to the geometric series forms. So that's going to be the sum from 1 to infinity of 516, and instead of doing 10 to the minus 3 to the power of n, 10 to the minus 3 is the same thing as 1 divided by 1,000 to the power of n. Because once I do this, I am now in the formula for a geometric sum. And remember that a geometric sum, so from 1 to infinity of a r n, if the absolute value of the ratio is less than 1, it means that it converges, right? So if the absolute value is less than 1, then the sum, so the sum from 1 to infinity of a r to the power of n is equal to a sub 1, where a sub 1 is just the first term, whenever we're adding this, divided by 1 minus r. So the question is, now that we were able to expand this decimal, we were able to take this decimal expansion, this point, so over here, this 0.516, 516, and so on, and we were able to express it like this, where this is a geometric formula, right? So what we have to do here is we have to check, is the ratio, the absolute value, less than 1. So the ratio, if you can see here, the ratio is the thing that's being raised to the power of n. So in our case, the thing that's being raised to the power of n is 1 divided by 1,000. And since 1 divided by 1,000, the absolute value, is definitely less than 1, it means that the sum here, it does converge, right? So once we're here, remember that our formula, since we know it converges, is a sub 1 divided by 1 minus r. So let's plug this into our formula. Let me erase this and let me erase that. So we're going to say that this is the same thing as a sub 1, and a sub 1 is just the first term, like when we expanded this. So if we plug in n is equal to 1 here for the first one, we're going to get 516 divided by times 1 over 1,000 to the power of 1, which is just 516 over 1,000. So and let me just write this down here. I'm going to improve this here. So we're looking for a sub 1 divided by 1 minus r, where a sub 1 is the first term, so that's going to be 516 over 1,000. And our ratio is going to be 1 divided by 1,000, right? So 1 divided by 1,000. So let's plug it into this formula here. So we have a sub 1, so 516 divided by 1,000. And all of that divided by 1 minus r. So 1 minus the ratio 1 divided by 1,000. So once we're here, we can then simplify this into saying, okay, that's 516 over 1 minus 1 divided by 1,000 is just 999. Oops, I wrote this wrong. So that's going to be 516 divided by 1,000 all over 1 minus 1,000 is 999 divided by 1,000. And if we look at this, we can see that they have the same denominator. So since they have the same denominator, we can just cancel these out and say that's the same thing as 516 over 999. However, we are not quite done yet, because this whole thing that we did was just the decimal exponential part, right? So what we did here was we took the 0.516, 516, and so on, and we rewrote this as a sum of 516 times 10 to the minus 3 to the power of n. And once we applied that in our formula, our a1 over 1 minus r, we found that the decimal part is 516 over 999. So now we have to go back here, because remember that 2.516 is the same thing as 2 plus the expansion of 0.516. So our total sum is going to be 2 plus, and as we saw, this decimal expansion here is just 516 divided by 999. And that is our answer. And if you do want to put this into fractions, right? So let me join these. So that's 2 plus 516 divided by 999. Let's see what that gets us. That's going to be the same thing as 838 divided by 333 if you were to simplify it. So this over here is our final answer, 838 plus 333, which is the same thing as 2 plus 516 divided by 999. And that is it for problem 33.